So we've solved for the price of a bond using different coupon rates, and now we are going to solve for what is the yield to maturity on a bond. And so if you look at this example, it's a 10-year 9% coupon bond, always $1,000 par value, and the price is $887. So they've given us the price, but they want to know the yield to maturity. Well, the yield to maturity is the RD, or the opportunity cost of debt. And so you can see if you set this up the equation method where you had the price is equal to all of the cash flows, which if it's a 9% bond, then the coupon payments will be $90. And then at the end of 10 years, you'll get your $1,000 back and your last $90 coupon payment. Well, you can see that you would have to figure out some rate and keep plugging this in until you found the right number that made the present value of these cash flows equal to 887. So if you first tried like 9.5, then you tried 9, and this would take forever because you would be constantly trying new numbers and to make this equal $887. And so this is why the calculator is great, because it solves this process really quickly. The calculator can do an iterative process where it gets the right answer. So here's the calculator solution for this question. You can see that we have our 10-year bond, price of $887, the payment was $90, and $1,000 future value. And if you hit compute I, you get the 10.91. So over here, if I hit 10 in for this example, and then 887 and negative, because I'm assuming that I'm investing in this bond, that's the present value. I get $90 coupon payments, and then I get $1,000 back as my par value when the loan is over. And then I hit compute I to solve for the yield to maturity. And you see we get the 10.91, which is what the answer is. And so this could tell us, well, currently in the bond market, interest rates have gone up because this was originally a 9% coupon bond. And now if the company, or well, really from the investor's point of view, if you're investing, you could get 10.91% on bonds. And so that's why the price is a discount, or less than $1,000, relatively a cheaper price for bonds. And then the other question is, what if we found the yield to maturity if the bond price was $1,134? So now we're finding the yield to maturity for a premium bond. And you see that the answer that we'll get is 7.08%. And this is selling at a premium now because interest rates have gone down. And if you were an investor, if you had the bond, you were getting 9% interest, and now if you're in the market trying to find a bond, you can only get 7% interest. So this bond is more expensive to purchase. And so to illustrate in the calculator for this one, we have 10 in 1134.20 negative, because that would be the price, present value, 90 payment, and then 1,000 future value. And then I hit compute I, and I get the 7.08% that we see as the answer over here. And now we have a way to divide up the yield to maturity into two components. So this expected total return equation right here is really saying that's the yield to maturity. It's equal to the expected current yield plus the expected capital gains yield. This is the same thing as if you were looking at a dividend, and there's a dividend or a total return for a stock. It's made up of the capital gains that you would receive for the change in price for the stock, plus the dividend yield, which would be the current dividend divided by the current market price. So this is really like the same thing. We have two components, capital gains and like a yield based on the coupon payments for a bond. And so to calculate the current yield, it's really simple. You just take the annual coupon payment amount. So if it's semi-annual, you need to make this an annual payment, what it was, divided by current price, and that will give you the current yield. And capital gains yield is just the change in price for the bond divided by the beginning price. And so that just means we're getting a percentage change. And just remember that the sum of those two is equal to the yield to maturity. So here's an example to find the current yield and the capital gains yield. If you have a 10-year 9% annual coupon bond that sells for $887 and has a face value of $1,000, first we want to know what's the current yield. Well, if it's a 9% coupon bond, then 9% times 1,000 is equal to 90. So I've got the annual coupon payment divided by the price of $887. So the current yield is 10.15%. And just remember, if you're doing a calculation, always distinguish the current yield from the yield to maturity. Sometimes a question will say, what's the current yield? And students try to solve for the yield to maturity, and it just messes people up sometimes. So if the yield to maturity is equal to the sum of these two, we had solved for the yield to maturity on a previous slide where we had 10.91%. And so if we just subtracted, say, the yield to maturity minus the current yield, which we got 10.15, then that leaves us with the capital gains yield. So this was the example that we had before when we computed 10.91%. This was for the discount bond, its yield to maturity. And likewise, if we had the yield to maturity and the capital gains yield of 0.76, we could say 10.91 minus 0.76 is equal to the current yield. So as long as you have two out of the three, you could solve for the third one.